I was typically interested in programming and mathematics from my from high school, and wanted to pursue that, but I ended up doing a master's in manufacturing and automation. So I find data science very close, where I can use those skills and follow my passion along with it. So I find it a good match.
So I'm interested in applications in healthcare, especially not quite data science, but more computer vision. But I guess because the essential paradigm remains the same across more or less most machine learning problems, so it's interesting to see how different people are using different things, and then you can pick up one technique from one place, try it in applications in other domains. So that's precisely why I'm here to see different kinds of applications.
Because everyone needs to know it precisely because we have a lot of information around us even while researching for something which is in a not necessarily in information technology domain. So there's so much data, we need to extract the best out of it to suit our needs. So I think everyone needs to know it and learn it. So thank you.
Okay, so thanks guys. So why we are here is because what we see is that data science is changing how the world has been operating in the last 5 years. Yeah, so data is exploding around us, and that's because now more and more transactions are happening digitally rather than happening on the ground, which means we have a lot of data, which gives us a lot of opportunity to optimize transactions are happening for various, okay, for various different business goals, right? And so there's a lot of different innovations across the world, which this burst in data and the advancements in algorithms is creating. And what we wanted as a company, we use a lot of data science in building our products, right? So the assessment products which we build and the predictive analysis which we do on top of these assessment products use a lot of data science. So we've been doing it for the last 5 years. And we thought that we should share this with all of you guys here, who are out here, because we think data science will be pushing the envelope of innovation in the next few years, but also paying economic dividend to businesses in the country, right? So it's just making all businesses look much better, be more efficient, and helping us do all better. So we said, okay, fine, let's interact with people, the young people out here, and tell them about data science and hear from them what they're doing in data science. So that was the basic idea. This is the first time we're doing something like this, so it's an interesting experiment. And Dr. Uname O'Reilly was coming to India, so I thought this was a great opportunity to hear what is the state of art happening in the world in machine learning. She represents the Alpha Group in CSAIL, the Computer Science and Artificial Intelligence Laboratory at MIT. Uh, she was my advisor at MIT, so we spent a couple of years together, 2005 to 2007, where we did some interesting work of applying optimization and machine learning to optimization of circuits. Uh, she's got several awards, so you can just go and check her webpage.
Hello, 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 hello.
She's an expert in complex systems, and there's a lot of puns which are around this word, but she's interested in lifelong learning, or has a lifelong interest in learning, and learning being here both machine learning but also human behavior learning as that comes. So we'll start the day with her telling you more about why machine learning or why data science and the basics of data science. And from that, we'll get into a hands-on session where we'll hopefully spend 1.5 hours where all of you actually do one whole loop of using machine learning on a problem. And the hope is that by doing that hands-on, you will learn how to do it and how to do it yourself. And the idea we want to communicate here is that you can do it yourself, right? It is today accessible in a way with whatever infrastructure is built already on the web and what things are available and how we understand the science. You can do it yourself, and it can yield results which are really useful, right? So it's not just something which is theoretical, which you submit as a BTech project, but it's something which can really be used by the industry, by companies, or yourself, right? So with this short introduction, I'll give it to Dr. Uname O'Reilly, and she'll take it from here.
Thank you. That's great.
We didn't get the pointer, right? We did?
So it's a pleasure to meet you all, and I hope over the course of today you get a chance to meet me better. I realize that there's a diverse set of backgrounds here, and in advance, I didn't know any of you, but I had to prepare my material before I arrived. So you're going to get some material that I think will be basic for you, but maybe not basics for others amongst the audience. Just going to do my best and go through it. Feel free to ask any questions as I go along, and I really enjoy it when people are interacting. So this picture I like to put up is here. The world is full of humans and systems, and sometimes humans are part of those systems, and sometimes those systems are machines, right? You can have systems like a car, which is completely censored in terms of how fast it drives and where it's going. But it's also a system when the human driver gets inside. And when the human driver gets inside, there's another piece of data we can collect, because we can collect the plans and goals and behavior of the human driving the car. And what's going on these days is that all these systems that are so complex are working faster and with more complexity than ever before. And if that weren't enough, there's an opportunity to understand them better, despite them becoming more complicated. And the reason we can understand them better, whether it be humans understanding ourselves, or machines, or humans and machines as systems together, is that these days we collect so much data. I'm not calling it information. We collect so much data, which are the observations of these systems behaving. Right? When I shop on the internet, everything I do, my behavior is recorded and is cross-referenced to that content that is in front of me that I interact with. And I don't know where the systems come and go. Is the system Amazon selling me products? Or is the system me buying products and browsing Amazon? Regardless, a set of data, huge amounts of it, just for me and for every one of you, is being collected. Now what we want to do is make sense of that data. We want to make sense of that data so we can understand those systems better, right? The things we want to do with those systems is we might want to say, well, if we know what happened in the past, we can predict what will happen in the future in similar circumstances. We might want to take what happened in the past and develop a model of our system based on those observations. And what those models let us do is they let us go back and extract more information about the system than we saw in the past. These systems are so fast often, and they're so complex because they have many interacting parts, that going back to the data retrospectively and forming models of the system can be extremely informative. And this can give you all sorts of advantages, right? So what I'm showing you here is data just raining down on the world, right? And it's being collected from all of these complex systems you see. And I'm showing you right on the far right, a student learning online. And I'm showing you on the far left a car, and it may as well have a driver, and I can talk about those things. And there's a whole slew of complex systems for which we're recording data. Name some for me. Where's data being recorded besides the internet? Anyone got any ideas? Where's data out there now? Hands up? Give me some ideas of where the data is. I'll bribe you with gifts from MIT. Back.
Which collects yeah, so telematics basically, so they collect data about the engine performance from the ECM and the ECU, and then they use it to optimize routes and optimize other things, how the driver should drive. So it is typically used in e-commerce and other industries. So that is one way apart from it.
Right. Other ideas? There was someone here who was interested in healthcare. Where's the data in healthcare?
We also get data from when we travel in metro. So may we collect the data how much passengers is going on a different route, and we have to enhance some route and number of trains, and
That's human behavior, but interacting with the system of transport, right? Another idea. Who's got your data? Think about it.
So there's EPR always, electronic patient records. But recently, so big shots like Siemens and GE have been making X-ray machines which are collecting all of the data, and it's all being uploaded to the cloud. So doctors across the world have access to, they can basically suggest their own views on a particular case. So it's bringing doctors together in some sense.
Sure. Other ideas in healthcare, other ideas in other domains. I'm sorry, I can't hear where it's coming from. We'll get you a mic.
The banking sector, where the transactions going on, and
Bank transactions, of course, yeah.
there is a major one, and where to increase the resources.
Right, absolutely. Other ideas? You each should have at least 3 at the back.
With a lot of sensors on the roads, you can collect the information of the cars moving, and then you can automatically enable and disable the red lights.
Perfect. Traffic, right.
Weather data is being collected.
Yep.
Geospatial data, like you have to construct a fire station, so you can collect the data and to predict where we can build a fire station or some hospitals.
That's a great idea.
You can collect the data about a particular person, so for surveillance purpose.
Oh, ooh, yes. Big government.
Through check-ins through on Facebook, on Foursquare, on Twitter.
Yep,
Check-in
social
data.
media. Right, that's another great source of data.
there is abundance of data on stock market which we can predict.
Yeah, stock market, that's that. If we can figure out how to take all the data from the stock market and figure out what's going to make people invest and where prices go up, that's great. Yeah.
So we get the major portion of data from the online transactions like e-commerce, the pattern on which people buy products. So we can predict what product might be the future product or something like that.
Perfect. Okay. Well, let me go on. I'm going to tell you that this data really interests me. I'm interested in extracting the knowledge from it. So I have a research group at MIT. It's called AnyScale Learning for All. And if you use those letters, it spells alpha. So we call it the Alpha Group. And what we're doing at the Alpha Group is we're building platforms and technology around scalable machine learning.